this presentation, I will take you with me into our research on model-driven architecture for interactive digital twin cockpits. This work is part of the research activities of the Chair for Software Engineering at RWTH Aachen University within the German Excellence Cluster Internet of Production. My name is Judith Michael. I have the pleasure of presenting you the joint research activities of Professor Bernhard Rumpe, Manuela Dalibor, Simon Wager, Andreas Wortmann, and myself. What is the motivation behind our approach? We have investigated the injection molding process. The figure on this slide shows a production plant which creates plastic parts. Plastic granules are inserted through the hopper into the injection unit, where they are heated. The molten material is injected under pressure into an injection mold. The clamping unit keeps the mold closed during this process, so that the mold halves do not open up. After a cooling time, the machine ejects the workpiece from the mold. During this process, temperature and pressure sensors measure the process parameters. These already indicate the quality of the produced workpiece. Injection molding machines are highly sensitive to stress and contextual changes, such as the environmental temperature. This means the same configuration does not always yield workpieces of equal quality, but an experienced operator can derive how to adapt the configuration to meet required quality criteria. To create the digital twin for such a system, we need the models and contextual data traces of this cyber-physical system. Moreover, the digital twin provides services to use the data and models. Such a digital twin needs interfaces for human interaction, namely a digital twin cockpit, which allows to supervise the machine and components. It provides live visualization of relevant process parameters to make quality checks possible. The digital twin cockpit provides a control interface and ensures different views and rights for various user groups. Clearly, such cockpit should evolve together with the digital twin and the physical system it represents. We propose the model-driven development of such digital twin cockpits, as the development is time-consuming, requires domain knowledge and good software engineering skills. As such digital twin cockpits should adapt to changes of both the physical system and the digital twin, we allow for this flexibility by using model-driven engineering methods. To create the digital twin cockpit, we reuse the class diagrams describing the data structure of the digital twin for generating the cockpit. This common data basis provides consistency by construction and has an immediate impact on the generated code, as the digital twin cockpit always fits the digital twin. Visualizations in the cockpit are generated using graphical user interface models. The data accessible at runtime is part of these GUI models and conforms to its representation in the class diagrams. This means visualization in the front end are also in sync with the data provided by the components of the digital twin. In our paper, we have proposed a digital twin cockpit architecture on 5 layers, which includes the cyber-physical production system and its control interface, the data lake, which provides data from different information sources, as well as the digital twin and its cockpit. The digital twin provides functionalities for live monitoring and controlling of the cyber-physical production system. The digital twin cockpit visualizes digital shadows that provide, for example, real-time information about the cyber-physical production system state, and it allows for user interaction. To get more information about our work, have a look at our paper, where you can find details about the model-driven development of digital twin cockpits using MontyGem, our generator framework for enterprise management. Find information on how to integrate digital twin cockpits and digital twins, details about the architecture briefly described before, and the generated digital twin cockpit for the injection molding process discussed at the beginning. For more publications about model-driven digital twins and generating information systems, check out our website.